Problem number 31, we're looking at how long our cell phone battery will last with continuous use. They tell us that this is normally distributed, the time that full charge will last is normally distributed with a mean of 10.3 hours and a standard deviation of 1.2. We're using the calculator to answer the questions. So what proportion, that's going to be part of the area under the normal curve, so we'll use normal CDF to find these. What proportion of batteries last more than 12 hours? So that's asking what's the probability that x is greater than 12, where x is the time that our battery lasts. That's our random variable. So if we sketch a distribution curve here, we have got a mean of 10.3 hours in the middle. And then we want to know x greater than 12, so 12 is over here to the right somewhere. And we want to know proportion of area that's above 12. So lower cutoff is 12, upper cutoff is infinity, so this will be normal CDF. Lower bound 12, upper bound, we'll use a big positive number, 10,000. And then you got to put your mean and standard deviation in because we're looking at x values, not z. So 10.3 for our mean and 1.2 for our standard deviation. Let's go to the calculator. So second variables, 2 for normal CDF, 12 is our lower, upper bound, 10,000, mean 10.3, sigma 1.2, 0.0783. So this area, which is proportion of data, 0.0783. What proportion of batteries last less than 10 hours? So less than 10 hours, let's sketch that distribution. So we got 10.3 here in the middle, that's our mean, and 10 a little bit less than that, and then we want less than 10 hours. So that's going to be this area here. So we want proportion of the area under the curve that's to the left of 10. So our lower cutoff minus infinity, upper cutoff 10. So we'd represent this like this, probability that x is less than 10. So that's going to be normal CDF. We'll do negative 10,000, big negative number, up to 10. And then our mean is 10.3. And standard deviation 1.2. And let's go ahead and enter that in. So second variables, number 2, let's see, lower negative 10,000, upper 10, 10.3 and 1.2 stay the same, 0.4013. So about 40% of the area is below 10. And then lastly, what's the probability a randomly chosen battery lasts between 9.2 and 11 hours? So that's saying we sketch our bell-shaped curve, that proportion of the data. We've got 10.3 in the middle, and 9.2 is below that, and 11 is above that. And so that probability, probability here, probability corresponds to proportion of the data, corresponds to area on the bell-shaped curve. It corresponds to this area here between 9 and 11. So that'll be probability that x is between 9.2 and 11. So that's how we write it in symbols. So it's going to be normal CDF, our lower cutoff 9.2, upper cutoff 11, 10.3 our mean, and 1.2 standard deviation. So second variables, normal CDF, 9.2 to 11. Other information stays the same, 0.5405. So that area in there, 54.05% of the area. So 54.05% chance that a randomly chosen battery would last between 9.2 and 11 hours on a full charge. Mine doesn't seem to last that long. I think I need to replace my battery.